So welcome to Unit 5, Exponential Functions. This unit is really split into 3 different sections. The first section will talk about powers and radicals. We'll review the power laws from grade 9 and 10. So most of that will be a review. Then we'll move on to exponential functions, looking at the graphs of these functions. And lastly, we'll finish off with applications of exponential functions. So lesson 1, power and radicals. Again, we're just trying to review a lot of the things from before. So a power is composed of 2 factors, a base and an exponent. So b to the power of 4 here is an example of a power. This here, so usually the larger entity represents the base, and the smaller entity, or the superscript there, represents the exponent. The way we read this is b to the power of 4. So again, this whole thing is the power, this is the base, it's bigger, and then the superscript, the smaller value, is the exponent. This is equivalent to some sort of expression. The way you think about it is you take your base, write it out this many times. So our base here is b. We're going to write it out 4 times. 1, 2, 3, 4. And then you just multiply those values. So when you have something to the power of something else, you take whatever your base is, you write it down this many times, and then you multiply it. So let's take a look at another quick example. So let's say I had 2 to the power of 3. Again, you should be thinking that 2 here is the base, 3 is the exponent. So I'm going to take the base and write it down this many times. So 2, 2, and 2. I wrote down the base times, and then I'm going to multiply them. In this case, we can actually solve this. 2 times 2 times 2 is just 8. So that's essentially how powers work. Now, something that gets confusing or something that's tricky sometimes is to identify what the base actually is. So let's take a look at these expressions. They seem very similar in the sense that you see a 4 there, you see a 2 as the exponent, but you can see that there's negatives and positives, and this changes what the base actually is. So when you have a number to the power of another number, this will be your base. So your base here is 4, your exponent is 2. So what's the answer? Again, I take my base, write it out this many times. So I took my 4, wrote it out twice, and now I just multiply it to give me 16. You need to be careful here because here it's the bracket shows a -4 inside, and then we're going to square it. So the base here is not just 4, it's -4. It's this thing inside the entire bracket. So the base is -4, the exponent is still 2, and again, I take the base, write it out this many times, so -4, and -4, and then I'm just going to multiply them. So -4 times -4 is positive 16. This is where most people get confused because it looks like the base is -4, but in reality, you should rewrite something that looks like this. So the bracket doesn't include the negative because if it did, it would look like the second example here. Here, there's a negative off to the side, and then 4 as your base to the power of 2. So what's the base here? The base here is 4. The exponent is 2. And again, if we follow the same rules, I take my base and write it out twice, and I'm going to multiply it. The difference here is that there was a negative in front. So if I wanted to rewrite this, I could rewrite it as -1 times 4 squared. These mean the exact same thing. So because there's a -1 being multiplied by 4 squared, I'll take my 4 squared and multiply it by -1 to give me -16. So again, just a quick review. Here, If you just have a number to the power of something, the base is quite simple. It's a positive number, so 4, the exponent is 2. If the base has brackets around it, you take whatever is included within that bracket. So -4 was our base, the exponent was still 2. Here, if you have a negative up front, but it's not included in the bracket, that means it's the regular 4, the positive 4, that's your base. You're putting it to the exponent of 2, but at the end, you're multiplying it by -1 because that's what the negative in front indicates. So again, this should be complete review. So just keep in mind what scenario you have when you're working through these questions. So I'm going to show you a few examples and the rest you're going to try on your own. So let's start with the first one. What is the base here? Well, this is the same scenario as scenario 1, where it's just a positive number. So the base is 5. The exponent I see is just 3. And for the answer, again, I'm taking the base, writing it this many times. So 5, 5, 5. I've written 5 3 times. And now I'm just going to multiply it. 5 times 5 times 5 is 125. Let's take a look at this example. Again, the base here would be -7 because it's in brackets. That entire bracket indicates what the base is. So -7, and my exponent is 2. So I'm going to take the base, write it out this many times. So -7 times -7, which gives me 49. Again, I took the -7, wrote it out twice, and then just multiplied it. If I take a look at E, this is the third scenario here. The negative isn't included in a bracket as a part of the base, so I need to make sure that I only take this part, sorry, I'm just going to rewrite the 2 there, as my base. So my base here is 5, my exponent is 2, so based on this, I'll have to write 5 twice, so 5 times 5, but there's a negative up front. So I'm going to have to multiply this by -1 as well. So -1 times 5 is -25. So you're really just looking for these 3 scenarios. Again, if you have the numbers alone, that's the base. If there's a bracket, whatever's inside the bracket indicates your base. If there's a negative number to the exponent of something, again, that negative is actually indicative of -1 being multiplied by this power. So don't include the negative as a part of the base. I'm going to do I'll do 2 more examples with you, and then the rest you're going to try on your own. Let's take a look here. We have 2 to the power of 3 divided by 5. Now this you need to be careful because there could be other numbers surrounding your powers that have no impact on what you actually do to evaluate the power itself. So if I took a look at this, I can see that really the top is my power. 2 to the 3 is my power. So the base is 2. The exponent attached to that base is 3. So if I was to use the same rules, I have 2 times 2 times 2. So I took the base, wrote it out 3 times, and I'm multiplying it. But I can't just ignore the divided by 5. I know my numerator here is just 2 to the 3, which is 2 times 2 times 2. My denominator, I really did nothing to, so I keep it as is. So 2 times 2 times 2 is 8 over 5. The 5 was unaffected by any of this. Okay, so maybe I'll show you another fraction one, and then that's it. So if I take a look at this fraction, again, what's the base? Well, I see brackets. Everything included in the brackets is my base. So my base is half, and my exponent is 3. So what this means is I'm going to take my base, write it out 3 times. So half, 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 and then I'm going to multiply it. Again, you could put the multiplication sign, or you could just show brackets, same deal. And remember, when you're multiplying fractions, you multiply out the numerator. So 1 times 1 times 1 is just 1. And multiply out the denominator. 2 times 2 times 2 is 8. Okay, so the rest of these you should be able to do on your own. There are some extra ones here where you're going to have to work backwards. But I'm going to leave that to you on your own because I want you to think through those so that you master this skill. So you will be finishing this chart and submitting it through our Google Classroom. Okay, so just a couple more examples before we go, and then this will be a quick, short lesson. I just wanted to kind of introduce this concept again. You've been working with this since grade 9. It should be a quick review. So when it says evaluate the following powers, that means solve, find the answer for this power. Again, that chart was helpful because it allowed us to take a look at the base, take a look at the exponent, write it all out, the multiplication question, and solve. If you need to do that, do it. If you can do some of this in your head, then you can do that as well. So we could do both ways. So let's say we have to write it out. The base here is -3, it's in brackets, and the exponent is 3, which means I'm going to write -3 out 3 times. Now I just do the math. -3 times -3 is +9. +9 times -3 is -27. So be careful of the signs. So here we have a negative, which is a positive, times a negative is negative, and 3 times 3 is 9, times 3 is 27. So whichever way helps you, if you need to look at the signs all together and the numbers all together, that's just as good. If we take a look here, let's think of the base. Again, you should be thinking that it's not -5, but just +5. So again, we have one of those scenarios where there's a negative up front, but that just means a -1 is being multiplied by this power. So I have my -1, I'm going to write it as is. My base here is 5, and my exponent is 2. So I'm going to write out the 5 twice and multiply it, which gives me -25. Again, if you can go from here directly to here in your head, I'm totally fine with that. This is a fun one. It says -1 to the power of 6. So we have -1 as our base, and we need to write it out 6 times. So negative, negative, -1, -1, -1, and -1. The good thing about this is when we have just -1 or +1, we know 1 times 1 is just 1, times 1 is just 1, times 1 is just 1. So we know our final answer is just going to be 1, because no matter how many times you multiply 1 by itself, it gives you 1. But the sign is interesting here. So negative and negative makes positive, positive and negative, negative, negative and negative, positive, positive, negative, negative, and negative, positive. So you just have to work through the signs. We know 2 negatives give us positive, and then, but the positive and the negative will give us a negative, and you just keep going until you get your final answer. I'm not going to give you the trick here, but what I want you to try is I want you to try -1 to the power of 3, -1 to the power of 5, -1 to the power of 2, and -1 to the power of 4. Try all of these, and I want you to see if you can see a pattern between whether the exponent is even or odd or even, and if what impact that has on your final answer. Again, if you cannot see a pattern and you need to write it out, that's totally fine, but try these. So here the exponents are odd, 3 and 5. Here they're even, 2 and 4. So work these out and see what pattern you get. See what answer you get, and then try to form some sort of pattern from that. Taking a look at this, I have 9 squared. Again, the base is 9, and I'm going to write it out twice because that's what my exponent is, which is just 81. Here I have 4 to the 3, so my base is 4. I'm going to write it out 3 times, and I multiply it. 4 times 4 is 16, times 4 is 64. And I have this. Seems a bit more complicated, but all you have to do is remember BEDMAS. With BEDMAS, we start with brackets first, so I'm going to write it down here. We have negative bracket 7 minus 5 to the power of 5, so I'm going to leave the negative as is. 7 minus 5 is 2. I solve my brackets first to the power of 5. Next, with BEDMAS, I have exponents, so I'm going to do that next. So I'm not touching the -1 because my base is 2, but I need to write it out 5 times. So 2, 2, 2, 2, 2. And so here I have -1 times 2 is 4, times 2, 8, times 2, 16, times 2, 32, which ultimately gives me negative 32. So it helps if you're fluent in these timetables because that's going to help save a lot of time. The last exercise is rewrite the following as powers. So 36, again, this isn't something that's intuitive if you don't know your multiplication tables. What you should know is 36 is just 6 times 6 is 36. So that's the same thing as writing 6 squared because 6 was my base, but I multiplied it out twice based on this exponent. 36 is also interesting because I can also write negative 6 times negative 6, because negative 6 times negative 6 is positive 36. So this can also be written as negative 6 squared. So that's why that one is interesting. Let's take a look at 49. So 49, we know that that's the same thing as 7 squared, but there's a negative up front. So let's see what we can do. We have 7 times 7, which takes care of this 49, but we also have this negative. So let's put a negative 1 up front. So negative 1 times 7 gives me negative 49. If I keep the negative as is, I can rewrite this as 7 squared, and it makes sense because the 7 squared will give me 49 times negative 1 will give me the negative 49. If you put a bracket, so let me show you a wrong answer. So I'm going to write wrong answer. If you try to do something like negative 7 squared, you'll notice that that's the same thing as negative 7 times negative 7, which gives you positive 49. But because you wanted negative 49, you know that this doesn't work. So usually with exponents, especially when the exponent is 2, to get a negative number, you do need to put a negative up front. And finally, we have 1,000. 1,000 is a bit different, but whenever you have a number where it's just 1 and a whole bunch of zeros, you should think of tens. So if I do 10 times 10, that gives me 100, times another 10 will get me to 1,000, and that can be rewritten as 10 to the 3. Again, some of you may be like, why is Mr. T showing all these excess steps? I can just go straight to this. Again, that's fine, but this is what your thought process needs to look like. You need to find, well, how can I rewrite this as a multiplication so that every number that's being multiplied is the same number. So 36 is also equal to 4 times 9, but that doesn't help me write this as a power. I need a way to rewrite these numbers as something being multiplied by something else, or something being multiplied by something where that number is consistently the same. So here we had 49, 7 and 7, they're the same number. Here there was 1,000, 10 and 10 and 10, they were the same. And only if they are the same can we rewrite them as powers. Okay, so I want you then to, for homework, complete chart on the first page and do handout A. It does seem like a lot of work, but again, depending on your comfortability with multiplication, it should be very quick math. And in fact, if you take a look at handout A, it says something along the top like each of these should take like 10 to 15 seconds to solve. That's how comfortable you need to become with this multiplication. Thank you. So sorry, before we leave, I know there's a second part to this lesson, radicals. We're going to do that as a separate lesson. Thank you.